So now I'm going to go through and reverse the process, okay? So we're going to go ahead and factor this polynomial, this trinomial. We're going to factor it using what we call the AC method. So we're basically reversing the process for multiplication. So the AC method says you multiply the A and the C together. We now know that that answer is 210, okay? Then I take, try to factor out the 210, and I would factor this down, and I already know what the factors are going to be, so I'm going to save the time here. But you would have, 1 and 210, and 2 and 105, and 3, and so forth, and you keep going down. Well, I already know that 14 and 15 will be the correct factorization. So I'm going to take 14 and 15, and I'm going to use them to split up the 29x. Remember, when we multiplied this out, you take the 14x, 15x that are in the middle and combine them to get 29. So we're just going to reverse that and go backwards. So we're going to split this 29 up into a 14x and a 15x. Okay? Doesn't change anything except the appearance of the number, right? 14x and 15x add up to 29x, so they're equivalent. I need to also keep my 10x squared and my 21. Okay? Then I'm going to use the grouping method. Remember, we did grouping with 4 terms, where you take the first 2 terms together, pull out a greatest common factor. Here I have a 2 and an x that are common, and that'll leave a 5x plus 7. And in the last 2 terms, 15x plus 21, there's a 3 that is common. So I would take a plus 3, pull that out, and I get a 5x plus 7. Okay. Then I have a common factor of 5x plus 7. I'm going to pull that. It's a binomial. I'm going to pull that binomial factor out. And I'm going to be left with 2x plus 3. Okay, those are my remaining factors. This is my factored form. It is the factored form that we had before. I have it in reverse order. It doesn't really matter the order because multiplication is commutative. So 2x plus 3 times 5x plus 7, or the other way around, it doesn't really matter. Okay. But anyway, this is the AC method. So you find the AC value, factor AC into 2 numbers whose sum is in the middle, break that middle term apart, use the grouping method, and get your final answer. It's a long process. And so because it's a long process, I'm going to show you a shortcut. I'm going to call it the modified AC method. It starts out like the AC method, but then it's a little bit quicker in the end. Okay, so let's do this. So I'll call this modified AC. So instead of doing all this, we are going to use the AC that we had before, the 210. We still have to find the 14 and 15. So this does not change. I'll box it in blue because we still need to do that. Okay? So we got A times C, 210, break it apart, 14 and 15. Once we get to that point, we can jump right to our sets of parentheses. What we're going to do, remember when we had a lead coefficient of 1, it was just x squared as the first term. We put an x and an x in the first 2 terms, right? So it was 1x and 1x. Well, here I'm going to use this coefficient twice. So it's going to be 10x and 10x. Now that seems like that won't work. In fact, it really won't. I'll show you there's a trick to making it work. But if you were to think about this, 10x times 10x is 100x squared, not 10x squared, right? So I'm going to have to get rid of another 10 at some point, and I'll explain where that comes from. But right now I got 10x and 10x. Then I take these 2 numbers, the 14 and 15, and put them into the parentheses, okay? So it's going to look a lot like what we did when there was a lead coefficient of 1. The problem now is 14 times 15 also doesn't give me 21, it gives me 210. Also an extra factor of 10, right? So 10 times 10 is 100, not 10, it's an extra factor of 10. 14 times 15 is an extra factor of 10, it's 210 instead of 21. So to get rid of that extra factor of 10, notice that these have a common factor. Each set has a common factor. That common factor, if I pull it out and get rid of it completely, will eliminate that extra factor of 10. In this first set, let me do this. In this first set, I have a common factor of 2. So if I divide both of them by that common factor of 2, then the final result will be 5x plus 7. Works kind of nice. The second set of parentheses has a common factor of 5. So if I divide out the 5, the resulting factors will be 2x plus 3. Notice 5x plus 7, 2x plus 3. Those are my original factored forms. So that is correct. That's the right answer. But what's interesting then, if you were to think about this 2 and this 5 multiplied together, that gives you that extra factor of 10 that I was talking about. Okay? So what we're doing is we're dividing out by a total of a factor of 10. This should always work as long as there is no greatest common factor in the original polynomial. If there is a greatest common factor in the original polynomial, then dividing at this step will cause you to lose that. So you want to make sure to factor it out at the beginning and set it off to the side. I'll give you an example later on in another video where that happens.